Okay, my name is Afari Ernest. Today we are going to look at classification of data under statistics. And so before we begin with the classification of data, let's look at some of the terms under classification of data. And so the first one is raw data. The first one is raw data. And so when we say raw data is just a collected data or any set of data. And normally, because we are saying raw data, it means it is not what grouped. So any ungrouped data can also be classified as what a raw data. For example, if you have 2, 5, 6, 7, 1, this is a raw data. So it is what a set of data collected, right? Because it is not grouped into classes, you can classify this as what a grouped data. And so this is raw data, and you can also call it ungrouped what data. Okay, and the next thing to look at is arrays. So arrays basically, when we say arrays, we are referring to what any arrangement of raw data or any arrangement of a data set, normally in what ascending order. And so this one we are talking about what arrangement and normally in what ascending order. Okay, so an example, if you have, let's use this example. If you have 2, 5, 6, 7, 1, and you are being asked to arrange this in ascending order, or when you hear anything like arrays, the answer becomes what? It means you have to arrange this data set in ascending order. So starting with what? 1. The next digit is what? 2, right? And 5, you move to 6, you move to 7. So this is what arrays. So when we say arrays, it's basically what arranging the data sets in ascending order. And the third one is what? Variable. The third one is variable. And when we say variable is anything that responds to what? Change. So anything that varies, we can classify that particular data set as what? A variable, or we can classify that object as what? A variable. Okay, so under this variable, we have two types of what? Variable. That is the first type. We have two types. One is what? Continuous variable, and the second one is what? Discrete variable. Okay, so with continuous variable, we are saying that variable is what? In a continuous form. Do you get it? So in an examination, or let's say in a particular question, when they say a particular number, and that number ranges from what? 1 to 3, right? If you are talking about, or if you are finding the range from 1 to 3, and you are using what? Continuous, you are relating it to continuous variable, it means you don't have to miss any number from 1 to 3, right? So you start from 1, then the next number becomes 1.1, the next number becomes 1.2, the next number becomes 1.3, till you get what? The 3. So continuous variables, they take what? Decimals. The thing is in continuous form. Do you get it? So anytime you hear continuous variable, just have it in mind that that particular response to change, and the change is what? Continuous, right? It means you have 1, you move to what? 1.1 instead of moving to what? 2. And so example of a continuous variable can be what? Height. So you see, sometimes when they measure someone's height, you see the result will be, let's say, 2.6 meters, right? Yes, it means that person is 2.3 meters height. Then talking about weight, you can also say someone's weight is what? 8.6 kilograms. 8.6 kilograms. Or a certain object weight is what? let's say 3.5 kilograms. And also you can also talk about what distance. You can also talk about distance, because distance too, we have what kilometers, 98.3 kilometers, 10.6 kilometers. So they are all what continuous variable. And when you are talking about discrete variable, so I said continuous variable, they take what decimals, right? They take decimals. I said they take decimals. Okay. Then with discrete variable, they are variables that take what whole numbers, right? They take whole numbers. So when you are referring to human beings, you see we don't have 2.5 people, we don't have 2.5 people, we can't say we have 5.25 people, right? So discrete variables take what whole numbers. That is, when you are relating to human beings, you can say is what discrete variable, human beings. Then you can also talk about what, let's say mangoes, right? You can also talk about mangoes, so number of mangoes. So you can talk about mangoes, or let's say uh, number of oranges or mangoes, right? So they all, this one take what whole numbers. Have it in mind, this one take what whole numbers, whole numbers. So anything that cannot be divided into 2 or quarter is what a discrete variable. So just have this one in mind. And also we have what another term we call frequency. We also have frequency. And what does the frequency mean? Frequency means what the number of occurrences in a given what data. So for example, if you have 2, 4, 6, 3, 1, and you are being asked to calculate for what the frequency, or what is the frequency of the data set, the answer becomes what 1, 2, 3, 4, 5, because we have 5 what occurrences in this data, right? So the frequency is what 5. So when we talk about frequency, this is what we mean by the frequency. And we are going to also look at what frequency distribution. And so for frequency distribution and the frequency, we have frequency distribution, and for the frequency distribution too, we have 2 forms that we are going to talk about. That is grouped data and ungrouped frequency distribution. You can say grouped frequency distribution or ungrouped frequency distribution. So we have grouped frequency distribution. So with grouped frequency distribution, let's talk about the ungrouped first. For the grouped, we have to do some adjustments and explain that one too. So before then, this comes with a very simple explanation. So let's look at this one first. So when you are talking about ungrouped frequency distribution, this one is just like a raw data. It is a data set that has not been grouped into what classes. It's only a data set, a raw data given, just like the raw data that we dealt here, right? So for example, on group data, it can also be in a form of frequency distribution, as I said, which is in a table form, right? So looking at this, we can put this same example in a table form. Look, we have let's say we have the data, and we have its corresponding what frequency. So we have the data and the frequency. The data, the first one, we have what? We have 1, 2, 5. So we have 1, 2, 5, 6, 7, right? Okay. And so what is the frequency? 1 is only 1 in the data set, so 1. 2 is also 1, so they are all 1, 1. if in case 7 appeared 2, you would have written what 2 here, right? Yes. And so this is ungrouped frequency distribution. It's just in a table form, but it is not grouped according to what classes. It's just the raw data given, right? Yes. And so we are done with the ungrouped frequency distribution. So have it in mind that the ungrouped frequency distribution is just like the raw data, but the only difference is that when we say frequency distribution, here we are referring to what? The table, right? We are interested in what? A tabular form. But when you say raw data is just as when the data is in its what? Raw state, right? Not even in a tabular form. And so let's look at the fifth one, which is the sixth one, which is the grouped one. So we have grouped frequency distribution. We have group frequency distribution. And so with group frequency distribution, it is also termed as what? Categorical frequency distribution. They are the same. And so under frequency distribution, as I said, we have two things to talk about, which is what? Ungrouped frequency distribution and what? Grouped frequency distribution. And so with grouped frequency distribution, we are saying this side, it has been what? Grouped into what? Classes. But from group data, it is what? Not grouped. It's just in raw data, but what? In tabular form. So this one, we are going to look at it in what? A tabular form. But this one is what? This one is grouped into classes, but this one is not what? Grouped. But this one is very broad, right? So I have to just clean this one to get some enough space here to also explain the grouped frequency distribution. Okay, so please don't forget that I said the only difference between the grouped frequency distribution and the ungrouped frequency distribution is what? One is grouped in what? Classes, and the other one is grouped just like the raw data, right? Yeah, so have it in mind, don't forget. Okay, so grouped frequency distribution. Okay, so this is the last term under what we are going to do today, that is classification of data. But this one also has some terms under it, and so we are going to look at those terms under grouped frequency distribution. So the terms under grouped frequency distribution, the first one that I would like to talk about is what? The class interval. We have class interval. I hope you can all, and you will all also bear with me that when we are talking about interval is just like a range, right? A range. And so from a point to another point, that is what? Interval. And so if you have something like 1 to 9, 10 to 19, 20 to 29, you all know that this is what? Class interval, right? So you have 10 to 19, you have 20 to 29. You all know this is what? Class interval, right? This is class interval. This is class interval. And so we are saying it is class interval because it starts from this side and ends at what? This side. It is what? An interval. That is why we call this what? Class interval. Okay. The next one that we look at is what? The class limits. The class limits. And so class limits is found within it's also part of the class interval. So in some questions, it's either you see class interval or class limit. But this is the difference. When we say class interval is just like the range. So the interval between what? This 1 and 9. That is what? The class interval we are talking about. But when we say class limits, you see this one, it starts from here and end here. And limits can be a starting point or the ending point. And so this starting point is a limit, and this ending point is also what? A limit. But the range between them is what? The interval we are talking about, right? Okay, so this one, we call this one lower class limit, and we call this one upper class limit. This one is called what? Lower class limit. And this 9 is called upper class limit. I hope you get it. And so this 10 is also lower class limit, this 19 is upper class limit, and this 20 is lower class limit, this 29 is upper class limit. Do you get it? So we call this what? The first class, right? So this is first class, and this is what? The second class. This is what? The third class. So first, second, third. And so the upper limit of the first class is what? 9. In an examination, they can ask you, what is the lower limit of the third class? And so you look for it. This is the first class, second class, third class, and which one is the lower class limit? This one, right? And so this is the lower class limit, this is the upper class limit. And so we are done with the class interval, class limit. The next thing to look at is what? The class frequency, right? So frequency. And for the frequency too, you see, we talked about frequency already, that frequency is what? The number of what? Occurrences in a given data, right? Okay, so they can give you a raw data, plenty numbers, and ask you to group them. So after getting 1 to 9, you look for this interval from 1 to 9. Which numbers are within the data that can be, or that fall under this 1 to 9, right? Then you number them, you write the answer here. So assuming maybe you count them and you got what? 8 here, here 2, 3, and here let's say 5, right? So frequency, it means the numbers that fall within 20 to 29 is what? 5. We have 5 numbers that fall within 20 to 25 according to the raw data, but here we don't have any raw data, and so we are assuming we have the frequency. We will just take a question and look at it, but before then, let's just get the concept first. And so after the frequency, we also have class boundaries. We have class boundaries. We have class boundaries. Okay, so for the class boundaries, we are just looking at the points. We are looking at the points. Maybe we are to draw histogram, or we are to draw frequency polygon. We would need what? Class boundaries. And see, for calculating class boundaries, we use what? The class intervals. And ask yourself, how do you even calculate the class boundaries? Before then, you have to calculate what? The boundary, right? You have to calculate the boundary first. And so how do you calculate the boundary? The boundary is always calculated this way. You see, you have 1 to 9, 10 to 19, 20 to 29, like this. So always, it's just a diagonal from the difference between the diagonal divided by 2. And so the left diagonal like this, or this, right? Then you divide the result by what? 2. And so this one, 10 minus 9, this 10 minus this 9 divided by 2, you are getting what? 1 over 2, which is 0.5. Or you can take this one, this diagonal divided by 2, the difference between this diagonal divided by 2, that is 20 minus 19, right? 20 minus 19, then you divide it by 2, and so this one too, you have 1 over 2, which is 0.5. So anyhow you do it, you are still going to get a common what? Boundary, right? And so you are not going to write this 0.5 throughout. You are not going to write this 0.5 here. You are now going to, because we are saying class, so you have to get something like this, an interval like this, right? But you are going to use this boundary. So this 0.5, you are to subtract the boundary from the lower class limit. If you subtract this 0.5 from here and you add this same 0.5 to this 9, I hope you get it. So here you have 1. So subtract 0.5 from 1. You get 0.5, right? So you have 0.5 2, then you add this 0.5 that you have subtracted from here, you add it to this one to get what? 9.5. And so the same time, you come here, you subtract 0.5 from this one, you get what? 9.5. So you see this one will just descend and come to this side to 19.5. So this one will also descend and come to this side 19.5 to what? 29.5. So this is the class boundaries. We are done calculating the class boundaries. Okay, so the next thing to look at is the class size or the class width. So the class size or the class width is class size, right? Class size or class width. Class size or class width. And so this one too, we have two ways of calculating for the class size or the class width. We have two ways. One, we say the class size or the class width is the difference between what? The class boundaries. And so this is the class, these are the class boundaries. So if you want to calculate for each class limit or the class size of every class, there's the first class, second class, third class. So in an examination, they can also ask you what is the upper class boundary of the second class. In an examination, it's either they will give you these two. So what is the upper class boundary of the second class? So this is the second class. So you have to calculate for the class boundaries and you look for the upper class boundary. So when you come to the class boundaries, this is the lower class boundary of the second class, and this was the upper class boundary of the second class, right? And so the difference between these two will give us what? The class size of the first class. And so we know this is the first class, right? So the difference will give us what? 9, right? The difference will give us 9. Is it? Yeah, it's 9, right? Or are you getting 9? Yeah, it's 9. 9 or 10. 9.5 minus 0.5 is 9, right? And 19.5 divided by minus 9.5 will also give us what? 10. This one will give us 10. And this one will also give us 10, right? Okay. But in most cases, this class size you get a common number for the class size. The reason why we are getting different class sizes is because of the numbers that we choose. But when in an examination, when we just tackle on let's say, or when we are about to solve a question, you just take a question and you see that the class size is just going to run through. So let me just change the numbers and you see that let me just set a proper example for you to also realize. So here we have 1 to 10, we have 11 to 20, we have 21 to 30, right? And we have the same frequency, right? So let us calculate the class boundaries again. So here for the boundary, 11 minus 10 will give us what? 1. Then we divide the 1 by what? 2, right? It's 11 minus 10. Then we divide it by 2. So it is 1 over what? 2, giving us 0.5. And so the boundary is what? 0.5. I said it is the diagonal. So you get 0.5. So now we have to subtract 0.5 from here and add it to this one. So here we have what? 10.5. And this 10.5 will just come down here. So we have 10.5 to 20.5. Then this 20.5 will come here. So we have 20.5 to 30. Sorry, yeah, we have 20.5 to 30.5. Okay, and so let's calculate the class size again. Now 10.5 minus 0.5 will give us what? 10, right? 20.5 minus 10.5 will give us what? 10. And 30.5 minus 20.5 will also give us 10, right? And so that is why I said for the class size and the class width, you will always get it what? Equal. They run the same, right? They are all, when you get the first one and the second one, you see that the numbers are the same. So you don't need to calculate for the rest. Just write the same numbers, repeat them. That is what class size or class what width. And I said, how do you calculate for it? That's the difference between the what class boundaries. That is one way of calculating for the class size. Another way of calculating for the class size or the class width is what? The vertical difference of the class interval. So you see 11 minus 1 is what? 10, right? That is what you see there. 20 minus this 10 is what? 10. That is what you see there. 30 minus 20 is what? 10. 21 minus 11 is what? 10. So it's either you do the vertical difference between the what class interval, or you find for the difference between what the class boundaries of every class. You are going to get the same answer. So if you don't remember this one, make sure you remember the vertical difference between the two, and they will all give you the same answer, right? Okay, so we are done with the class size. The next thing is what? Class midpoint. The next thing is class midpoint. Class midpoint. The next thing is class midpoint. Okay, so for the class midpoint 2, we are saying midpoint. And midpoint is just the mediator of what? A line, right? Or a class. So this midpoint, it means when we add the class interval and divide it by 2, we get the midpoint of this particular class, right? So I always tell you, have it in mind. In an examination, a table like this is how they can put the question. They'll just give you a data like this and ask you to calculate for the upper class boundary of the third class. So you have to calculate the class boundaries and you locate the third class. And for the class boundary, there is the first class, second class, third class. And which one is the upper class boundary? This one, right? So this one becomes the answer, right? Yes. And also have it in mind, they can also ask you to calculate for class size of the third class. So what is the class size of the third class? There is it. 10 is the class size. Class 1, class 2, class 3. So 10 is the what? Class size of the third class. Okay, so now let's look at the midpoint. They can also ask you to calculate for let's say midpoint of the second class. So it means you have to calculate for the midpoint here, because this is first, this is second, right? Okay, so let's look at how to even calculate the midpoint. We are saying we are to add the 2, right, and divide it by 2. So we have 1 plus 10 divided by 2. So 1 plus 10 will give us 11 divided by 2. It will give us 5.5. So the first class we have 5.5, and we also can do same for the second class, which is 11 plus 20 divided by 2. And this 11 plus 20 will give us what? 31 divided by 2. And this will give us what? 15.5. So we write the 15.5 here. Okay, and have it in mind, you see this one, we are having only 3 classes. In an examination you can have 10 classes, first class, second class, third class, fourth class, like that to the 10th class. Okay, so you ask yourself, that is why I said after getting the first 2 class size, you write the same thing so you get to the last class, right? So that you can save time instead of calculating for it one by one. Then when you get to the class midpoint 2, same. After calculating the first 2, you find for the difference. So 15.5 minus 5.5, what is it? That is 10, right? So it means the difference is 10. Now you can add the 10 to this one to get the next one. You add the 10 to this one to get the next one. So you get to the last class. So here we added 10 to 5.5 to get 15.5, right? So if you add the difference, which is 10, to this one, you get what? 25.5. That is it. Do you get it? Or if you want to do it one by one or separately, you can just do it by what I just did. This one you can also add it. 21 plus 30, right? So we say 21 plus 30 divided by 2. So 21 plus 30 will give you what? 51. And 51 divided by 2 is what? 25.5. And this 25.5 is here, right? So in order to save time, you just have to find for the difference between the first 2, then you add the difference to the numbers continuously till you get to the last class. You get it? That is it. Or have it in mind that I said the class size are always the same, right? So when you calculate for the first midpoint, which is 5.5, the class size is what? 10, right? So you add the 10 to the class midpoint to get to the next number, right? So you add the class size to the numbers till you get to the last one. I hope you get it. So assuming you see here 5.5, if you add this 10 to 5.5, you get what? 15.5. So if you add this 10 to this 15.5, you are getting what? 25.5. You get it? So the class size and class midpoint, they have some connection. So if you are smart enough in an examination, you can just save time instead of going through plenty calculations. If you have the class size, I said what do you do? Calculate for the first midpoint. When you finish, add the class size to the first midpoint. You add 10 to it, you get this number, you add. So assuming our class size was 8, after getting 5.5, we will have to add what? The 8 to 5.5 to get the next one. Okay, so that is the class midpoint. It's either you add the 2 and you divide it by 2 to get what? The midpoint, or you find for the first midpoint and you add the rest. You add the class size or the class size or the class width to the rest to get your class midpoints. Okay, so the next one we are going to talk about is how to even group this one. You see, in an examination that they can give you a raw data and ask you to construct this. So before then, let's also look at one last thing: cumulative frequency. We have less than cumulative frequency. So less than cumulative frequency, we are saying we are going to cumulate the frequencies. So you see we have 3 frequencies, right? As and when we are moving on, we are adding what? The frequencies. So the first one is what? 8. The first one is what? 8. So the first one is 8, which is the second one is what? 3. So instead of writing the 3 here, we will add the 3 to the 8 to get what? 11, right? Then this is what? 5. Here too, we will add the 5 to the 11 to get what? 16, right? So whilst we are moving on, we will be adding what? The frequencies. That is why we call it cumulative what? Frequency. But this is less than. But if you are to calculate for the more than cumulative frequency, more than cumulative frequency. Alright, so if you are to calculate the more than cumulative frequency, that is the opposite of this, right? So this frequency, when we were cumulating it according to the less than, we started from the top, right? And so the same thing, if you are accumulating it with respect to what? More than, you start from what? Down. So the first one or the last frequency is what? 5, right? So you write the 5 here, you are building it up. And this 3, you add this 3 to the 5 there, right, to get what? 8, right? And this 8, you add it to the 8 there to get what? 16, right? So this 16 is here, right? You see the relationship? Yes. So that is more than cumulative frequency. More than, we start from what? Down, and less than, we start cumulating the frequency from up to down, and more than is down to what? Up. So please don't forget it. So we are done with everything with respect to what? Grouped frequency distribution. Now we are going to look at how to even construct the group frequency distribution itself, because in an examination you are not going to get a table like this. You are to construct your own table, right? You have to construct your own table. And how do you even construct your own table? By grouping them into classes like this, your frequency, and to even continue with your calculations according to any question that will be given to you in the examination hall. So before then, let's get, so before you construct the table that we just calculated for the you see, we just calculated for some entries within the grouped frequency distribution table. Okay, and so before you even construct the table, you have to go through some procedures, and you have to use a certain formula. And this formula was named after a certain man who is called what? Sturge. And so the formula is named Sturge's what? Sturge's rule. Sturge's rule. And Sturge's rule says that before you get what? Number of classes, it is equal to what? 1 plus 3.322 log 10n, right? And so this n here refers to what? The number of occurrences or the total what? Frequency. So in a given raw data, they can give you 50 numbers, right? And so the 50 numbers, n is what? 50, because the observation occurrences is what? 50, and so you can say n is 50. So assuming we have what? N to what? 50, that is 50 numbers. So it means we have to put this 50 what? Here. And so before we get our number of classes, we have 1 plus 3.322 log 10 what? 50, right? And so this one too, you get 6.64. And so this 6.64, for the number of classes, we don't have what? Decimals. So always it has to be in what? Whole number. But when we are talking about number of classes, this one we round it off, right? And so it means if you have a decimal and after the decimal the number is 5, 6, 7, 8, 9, it means you have to add 1 to the whole number, right? So you know how to round off numbers. So 6.6 here means we have to add 1 to the 6 to get what? 7. But if we were to have 4 here, the answer would have been what? 6. Do you get it? So if the number is after the decimal, the number is below 5, you maintain what? The whole number here. But if the number is what? From 5 to 9, it means you have to add this one to it. So this is what? 6, right? So the approximation will be what? 7. So it means the number of classes is what? 7. The number of classes is 7. The number of classes is what? 7. And so when we draw our table, it means we have to get 7 classes. That is first class, second class, third class, fourth class, fifth class, sixth class, seventh class. We can't go to what? The 8th class. Do you get it? That is it. And after getting the number of classes, so it means you have to put this formula in mind. Now, after getting the number of classes, you have to find something we call class size or what? Class width. But if you have the table already, you know it is what? The difference between the class boundaries or the vertical difference between the class interval, right? That will give you the class size or the class width. But this one we don't have it, and so you have to use the formula to what? Calculate for class size or class width. And that one too, before you get to the class size, it is also equal to maximum number minus minimum number all over number of classes. So if you get the number of classes wrong, it means you are likely to get the class size also what? Wrong. So this one we have the class size maximum minus what? Minimum over what? Number of classes. But for the number of classes we have it already. This maximum is talking about in a group in a group distribution, or let's say in any occurrence or observation, those numbers given, you have to look out for the maximum number, right? And you look out for what? The minimum number. So assuming a data given and our maximum number is what? 75, and our minimum number is, let's say, 35, right? Our number of classes we have already calculated, which is what? 7, right? So this one will give us 40 over what? 7, and this is what? 5.7, right? Let's say 5.7. Yeah, 5.7. And this one too, we want what? Whole number. We don't want decimal, right? So this one 5.7, you ask yourself, I said here we do what? Round off, but have it in mind when you are dealing with class size, we do round up. We call it round up. It is round up because after the decimal, any number that you have after the decimal, even if it is 0 point, even if it is 5.0001, you still have to get what? 6. That is what we call round up. Do you get it? And you see, for the round off, if this number is not up to 5, we can't just round it to this side. Do you get it? Yes. And this one, it is 5.7, and so automatically we get what? 6. Even if it was supposed to be 5.2, we still have to get what? 6. So far as you have what? Decimal after it, you have to add 1 to the whole number. So note the difference between the number of classes and the class size is that for the number of classes, if you get decimal, you have to round it off. Rounding off means just look at the first decimal. If it is 5 going, you add 1 to the whole number. If it is less than 5, you maintain the whole number. So here, if it was supposed to be 6.3, like our final answer would have been 6, right? But because it is 6.6, our final answer is what? 7, right? And here too is 5.7, and we are getting 6. Even if it is 5.1, we still have to get 6. Do you get it? So have it in mind that for the class size or class width, always maximum minus minimum over number of classes, and you have it. And so okay, so we are going to look at this question. We are to construct a frequency distribution table from this question. So in an examination, you can be given a question like this, and they will ask you to calculate for, let's say, a third upper class limit of the third class. Also, they can ask you to calculate for, let's say, the value of or the midpoint of the second class. They can also ask you to calculate for anything. So you are going to construct a frequency distribution table from this, right? Okay. And before you start with your table, you first have to get the number of classes and the class width using what? Sturge's rule. So you first count the numbers here. That will be what? N. And so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And you also have 1, 2, 3, 4, 5. And so you have 50 in all. It means N is equal to what? It means N is equal to 50, right? So what does the Sturge's rule says? Sturge's rule. So our number of classes is equal to 1 plus 3.322 log 10 n, right? And here n is equal to what? 50. So we have 1 plus 3.322 log 10 50. And so the answer will be 6.64, right? And here we are saying if you get to number of classes, you round it to a whole number, right? You round it off to the nearest whole number. And because this is more than 4, which is, this starts from 5 going, right? So you have to add 1 to the whole number to get what? 7. So this is number of classes. So it means when we draw the table, we have to get what? 7 classes, first class, second class, till we get what? The 7th class, right? That is it. Then we are done with the number of classes. The next thing to do is what? The class size or the class width. The class size or the class width. And so the class size is equal to the maximum minus the minimum over what? Number of classes, right? And so what is the maximum value and which one is the minimum? So we look through the data. You see, for the maximum value, let's go through the data and see. We have 1, 2, 2 here. Do we have anything more than 1, 2, 2? We have 1, 2, 7 here. Do we have anything more than 127? Do we have anything more than 127? We have 134 here. So 134 is the maximum number, right? 134 is the maximum number. So the maximum number, we have 134 minus the minimum number is what? Let's also look through the minimum number. I think that will be 100 because they are all three digits and 1111. So the minimum number will be what? 100. So we are going to perform this calculation and see the class size, the value for the class size. So we have number of classes. So the number of classes is what? 7. You know, we started from the stages rule, we calculated for the number of classes and we arrived at what? 7. And so we are saying number of classes is 7. And so please don't forget, I said the number of classes according to the table is what we always have it as what? 1, 2, 3, 4, 5, 6, 7. That is number of classes. And for the class size is also the maximum value minus minimum value over the number of classes. So that is 4.857. So this one too, we have 4.857, right? And don't forget, I said with the number of class, with the class size or the class width, always we round it up, right? So this one is even 8, so probably it becomes what? 5, right? It becomes 5. And so you see, we have number of classes 7, we have the class size which is what? 5. Okay, so we are going to use this data to construct the frequency distribution table and also continue with our calculation. So please don't forget, the number of classes is 7 and the class size or the class width is also what? 5. Because of space, I'm going to clean this side and use the space here to also do the next calculations. Okay, so let's start. The number of classes is 7. The number of classes is 7 and the class width is 5. Okay, so this is how we construct the table. The first thing we are going to look at is what? Class interval. Class what? Interval. Class interval. So class interval is the first thing that we are going to look at. And you see, we have the number of classes which is 7. So it means we have to get first class, second class, so we get to the 7th class, and the class way to talk about the difference. So look at how we are going to do it. Here, before you start with the calculation, you have to look out for the minimum number, right? So before you even calculated the class size, you see, you first search for the minimum number and the maximum number, and you realize the minimum number was what? 100, right? And so we write the minimum number here. Okay, and so always you write the minimum number first. Now after writing the minimum number, you ask yourself what is the value of the class width. The value of the class width is what? 5. So you are going to add 5 to this 100 to get what? 105, right? So let me just open it up small. So you are going to get 105. So you are going to add the class width. You are going to add it this way. So 105, right? Okay. Now, because this is interval, we have to look out for the numbers here, right? And so this 105. You ask yourself, which number comes before this 105? That is 104, right? And so that 104 will come here. So you see, you have 100 to 104, 105 to what? So here too, you are going to add the class width, which is 5. You are going to add it like that. So immediately you get these 3 numbers, 1, 2, 3. You are done with everything because the rest are just a bonus to you. Okay, so this is 105. You look for the class width is what? 5. So you add 5, 5, 5, 5. So here will be 110. Here will be 110. We add 5 to this one to get 115. How many classes do we have now? 1, 2, 3, 4. We have 3 more to go. We add 5 to get 120. We add another 5 to get 125. How many classes now? 1, 2, 3, 4, 5, 6. One class more because we had 7, right? So we add another 5 to get what? 130. So we have 130. And so the same thing, we are going to add 5, 5, 5, 5 to this one. So we get to the 7th class. Okay. So this one, you add 5, you get 109, 114, 119, 124. Here too, you have 129, and 129, you have 134. And so don't forget, our maximum number in the observation is what? 134, which is here, and our minimum number is 100, which is also here, right? So we are done with the class interval. So this is how to get your class interval, right? Okay, so now we are going to look out for the frequency. And what did I say about the frequency? I said for the frequency is the number of occurrences, or the numbers that are within what? This observation. So from 100 to 104, the numbers there, that is what we are going to look out for, right? So the frequency for this first class, 100 to 104, let us look for those numbers, right? Let us look for those numbers. So the first one is what? 100, right? Okay, let's start from this side. 100 to 104. We look. We don't have any here, right? And so when you come here, we have 100. We cancel it out, right? So we have 1. We come. We don't have. Come here. We don't have. We come here. We have 2. We come here. That is all. So for this side, we have only 2, right? Then we also look at the second one, which is 105 to 109. So from the observation 105 to 109, we have 1, 2, 3. We look here. We have 4, 5, 6, 7. So here we have what? 7, right? Then we go to 110 to 114, right? We go to 110 to 114. Now 110 to 114, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think we have 109 here, which is supposed to be here, right? So this 109. Let's continue. Maybe when we finish, we count 105 and 109 again and look at it. So now we are dealing with 110 and 140. So 110 to 140, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 10, 11, 12, 13, 14. We also have this one, 15. We have this one too, 16. Then what again? 16. 16. So we have 16. Here is 16. So let's count 105 to 109 again. 105 to 109. We have 1, 2, 3. This is 4. This is 4, 5, 6, 7. So is this supposed to be 7? 7. Okay, so we can add this one to it to get 8. Yeah, so this side is supposed to be 8. Okay, so let's look out for 115 to 119. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This one is also 14. This one is also 14. 105 to 119. 105 to 119. Okay, we have 14. This one too, I think 15. Okay, so we have 15. Okay, so we have 15. Okay, then let's look out for 120 to 124. This is 120 to 124. So we have 1, 2, 3. 4, 5, 6, 7. So this one too doesn't mean we have 7. Then 125 to 129. So 125. Yeah, I think everything is cancelled here. This side to same. 229. So we have 1. This side is finished. This side is also finished. This side is also finished. So we have 1, and here 130 to 134 we have the last one, which is 1. Okay, so let's count. So this is 10, 36, right? 31, 38, 39. Sorry, this is 10. So 26, 41, 48, 49, 50. Okay, so we had n to be 50. So it means our frequency, from the frequency, we are not lying. We have cancelled everything, and our calculation is also right. So we move on to the next one. So now that you have established the class interval and the frequency, you move on. Maybe they can also ask you to calculate for class midpoints. So let's calculate for class midpoints. Class midpoints, and this is always represented by x. So class midpoint, and I said the class midpoint is what? The addition of the two, right? The addition of the two. And so the addition of the 2 divided by 2. So 100 plus 104 will give you what? 100 plus 104 divided by 2. And so this one will give you 204 divided by 2, right? And so this will give you 102. And so it means the first midpoint is 102. And don't forget, I told you, when you are calculating for the class midpoint and you have the class size, immediately you get the first class midpoint, you don't need to do any calculation. What you do next is you take the class width, which is 5, and you add it to the class, you add it to the subsequent numbers to get to what? Your last class. So the class width is what? 5. And so here you don't need to do this calculation, you divide it by 2, this calculation, divide it by 2. Immediately you get the first one, add 5 to this one to get to the next one, add 5 to the next one to get to this. So 102, you know the class width is 5, so 102, if you add 5 to it, what are you getting? You are getting 107. You add 5, you are getting what? 200, sorry, 112, right? 117, 122, 127, then you get 132. Yes, so we are done with the class midpoints. Then in an examination they can also ask you to calculate for the class boundaries, so let us also calculate for the class boundaries. So for the class boundaries too, I said always before you calculate for the class boundaries, you always have to calculate for the boundary, right? And what is the boundary? The boundary is what? The diagonal difference divided by 2. So this difference, so 105 minus 104, the diagonal, like this. So always like this. This difference is, so you can say 120 minus 119, it will still give you what? It will still give you 1 over 2, which is 0.5. You can say 130 minus 129 divided by 2, it will still give you 1 over 2, which is 0.5. So anyhow, anyway, you are going to get what? 0.5. So always have it in mind that when you are calculating for the class boundary, it is the diagonal difference divided by what? 2, as I said earlier. Okay, so that is it. The boundary is 0.5. So if it is 0.5, and remember please, it is not always 0.5. Sometimes the class interval can be 0.1 to 1, 1.1 to 2, 2.1 to 3. And if you are to calculate for the class boundary, this is just an example. If you are to calculate for the class boundary of this, you see we are saying it is diagonal, right? And so 2.1 minus 2 divided by 2, you are getting 0.1 divided by 2, and so 0.1 divided by 2 is 0.05. So you see it is not always 0.5. Sometimes you can get 0.05. Do you get it? And so if you get 0.05, that one becomes the boundary. You subtract it from here and you add it here. But this is not what we are doing. I just use this as an example. So what we are doing, we are saying 105 minus 104 divided by 2. So you are getting 1 over 2, 0.5, right? So the boundary is 0.5. So we subtract 0.5 from this one and we add it to this one. Okay. So when you subtract 0.5 from here, what are you getting? 99.5 to 104.5. And this 104.5 will drop and come down here to get 104.5 to 109.5. You add it here, and this 109.5 will drop and come down here to get 109.5 to 114.5, and this one will also drop 114.5 to 119.5, and this one will also drop. So you can just have it in mind. This one will drop, you bring this one will drop, you bring, or better still, you can just add the two. Sorry, you can still subtract 0.5 from here and you add it to this one. Anyhow that you want, you are still going to get the same answer. So this one will also drop, come here, 1 for you to save time, 1152, 119.5 to 124.5, and this one too is 124.5 to 129.5, and this one is 129.5 to 134.5. And so we are done with the class boundaries. And also let us calculate for the less than cumulative frequency and the more than cumulative frequency. And so the less than cumulative frequency right? And the less than cumulative frequency, we are saying when you are accumulating the frequency, you start from the top. And so the first one is 2, so you write 2 here. The second one is 8, so you don't write the 8 here, but rather you add this 8 to the 2 to get what? 10, right? And here 16, you add 16 to the 10 to get what? 26. And you add 15 to this 26 to get what? 41, right? You add the 7 to the 41 to get 48, and you add the 1, 49. You add the 1, what? 50. Okay. And so this is the less than. Let's calculate for the more than cumulative frequency. More than cumulative frequency. Okay, so for the more than, the less than, we said you cumulate it what? From up to down. And so for the more than, you start from down to up. So down, the first one is what? 1. We write the 1 here. The next one is 1, so we add this one to this one to get what? 2. So we are accumulating it upwards. The next one, you add this 7 to this one to get what? 9, right? So you add 15 to the 9 to get what? 24. And this one too, you add this 16 to this 24 to get 40, right? To get 40. And here you add 8 to 40 to get 48, and you add these 2 to the 48 to get 50. So always your ending should be equal to the total frequency, which is n, right? So you see here we ended at 50, and here we also ended at 50. So if the two ends are not the same, it means you are wrong. You get it? And it must always equal to what? The n, which was already given. N is what? The number of occurrences here. So always you always have to get what? The number of occurrences as the final answer when you are calculating the frequency. So this is the practice set question. Let's move on to how to construct histogram and frequency polygon. Histogram and frequency polygon, and we end classification of data. Okay. So we are going to look at histogram and how to also draw histogram when you are given a data like this. Okay, so you know histogram, you know bar graph, block graphs, you know bar graph, you have space between them. Histogram, they are closely what? Packed, right? But for histogram, we are going to use what? Class boundaries. We are going to use class boundaries to draw what? Histogram. And so here in a question, you have been given this, right? And so you have to calculate your own class boundaries and use the class boundaries to draw what? The histogram. I hope you get it. Okay, so here from the data, we would have to calculate what? Class boundaries before we can establish a proper frequency graph. Okay, so let me clean the histogram here and write class boundaries. Right, so for the class boundaries, you have to calculate the boundary first, and you know it's diagonal, right? So here it is what? 20 minus 19 divided by 2, and so you have 1 over 2, which is 0.5. So the boundary is 0.5, so we subtract 0.5, we add it here, you know already. So we subtract from here, we have 9.5, we add it here to get 19.5. We bring this one down to get 19.5 to 29.5. We bring this one down 29.5 to 39.5. You bring this one to 39.5 to 49.5. 49.5 to 59.5. Yes, so we are done with the boundaries. Now let us draw the histogram. Okay, so for the histogram, you have a break, right? You have a break here, right? So you have it like this. Okay, so let me just expand it so that it doesn't become too small. You have a break here, Okay, so here is your class boundaries, because you are going to use the boundaries to draw, right? And the boundaries start from where? 9.5. Here is 0, and you start from here is 9.5. You come to 19.5, 9.5, 19.5, 29.5. You go to 39.5, move to 49.5, and the last one is 59.5. So you start from the minimum like this and you bring it here, so it is always like this, right? 7. So you start from here and you bring it down, so this number and all of this. Okay, so now you bring your what? Your frequency. You bring your frequency here, you bring your frequency here, and for the frequency to what is the maximum? We have 6, so we can use difference 1. So this is 1, this is 2, 3, 4, we have 5, and we have what? 6, right? Okay, so you ask yourself, the first boundaries, which is 9.5 to 19.5, what do you have here? The frequency is 2, right? So you draw it like this. So that is 9 to 19.5, you have 2, right? So you have your histogram, shade it nicely. Then the next one is 19.5 to 29.5, you have what? 4. And so 19.5 to 29.5, you have 4. And so this one too, because they are packed, you see we are starting from 19.5, which is on the same line, so we have to extend this line to 4. Then we bring it here, sorry, we bring it here. Okay, still I'm not getting a straight line, something like this. Okay, so this one to shade it nicely. And the third one is what? 29.5 to 39.5, and the frequency is 6. So this one to get, you extend it to 6 and you bring it to this boundary, shade it nicely, shade it nicely. Okay, and the fourth one is 39.5 to 49.5, 39, and the frequency is what? 2, right? And here 2 is here, so we bring it this way to this side and we shade it nicely, shade it nicely. Okay, and the last one is 49.5 to 59.5, and that is 1, and 1 is here, right? So we bring this one to this side, we shade this one too, and so we can say this is our what? Histogram. You bring your title, our histogram, right? And so this is how to construct the histogram. And yeah, this is how to construct the histogram, so have it in mind. We are done with the histogram. The next thing we are going to do is the frequency polygon. The frequency polygon and the histogram, there is no difference, but for frequency polygon you don't have class boundaries, right? For the frequency polygon you don't have class boundaries. All that you have is the midpoint, and that one you are just going to join the midpoint that is here and here. So let me just give an example of frequency polygon, and we also draw the chart. Okay, so let's look at how frequency polygon. So for frequency polygon we don't have something called class boundaries, so we take the class boundaries off. We are done with histogram. Okay, so here too we don't have class interval, so we only have midpoints, right? So with the frequency polygon, let's quickly round through. We have 1, let's say midpoint 1, midpoint 2, 3, 4, 5. This is what? Midpoints, or it can be named ages, weights, whatever, right? And so here you draw the same graph, but there is no break, only histogram has a break, and here it is going to be midpoint. Always the vertical side is what? The frequency, right? So here you have 1, 2, 3, 4, 5, and this vertical side is the frequency. So 1, 2, 3, 4, 5, 6, and this is the frequency, right? So for 1 we have what? 2. 1 we have 2. So you draw it like this. And the second one we have what? 4. So 4. You bring it this way. This is also closely packed. Okay. And the third one is 6. So you bring this one to 6 and you bring it here, right? Then the fourth one is 2. You bring the 2 here, right? And the fifth one is what? 1. And so for the fifth one too, for the fifth one is just 1. So you bring the 1 here. That is 5, right? And so that is frequency polygon. This is frequency polygon. Frequency polygon. Frequency polygon. This is frequency polygon. And for the frequency polygon, because we have midpoints, you are going to join all the midpoints together. And so there's the midpoint, right? 1. So you join 1 to the middle of this, and you join the middle of this to the middle of this. Then you join the middle of this to the middle of this, and you join this middle to this middle, right? And so this is a frequency polygon. A frequency polygon. And so don't forget, cumulative frequency is the same as ogive. And so in an examination they can ask you ogive is the same as, you see cumulative frequency, you see frequency polygon, but the right answer is what? Cumulative frequency, but not frequency polygon. So that is it. We are going to end here for